As Group 1 of the Fitch 2025 Codeathon, we are proud to introduce to you our submission of the project for now. My name is Sumya.
And my name is Tanish.
My name is Alan.
And we'll proceed to explaining our pipeline after we review this take.
For this Codeathon, we're provided with several data sets containing informations of company, such as revenue, environmental activity, and sustainable development goal announced, etc. The final goal of this Codeathon is came up with a model that can predicts direct and indirect emissions from the company based on the information provided. And we will start introducing our project by the solution pipeline.
Our solution pipeline is as follows. We're given data, and then we observe the data, and then we pre-process the data as well as clean the data, and then we do baseline observations, which help us make basic correlations. And through those basic correlations, we derive, at least our team derived 19 different hypotheses, which were based on real-world correlations and other observations and logic. And then we narrowed those hypotheses down to 5 hypotheses, which were going to be backed by real data. And then that data would train the language learning model.
Our finalized 5 hypotheses considers various factors, such as a company's sector industry, environmental activities, weighted SDGs, and revenues, along with risk factors that might affect our models on making predictions on emissions. Our repository contains further explorations and analyses on the proving process of these hypotheses. And then next, I will hand over to our teammate Tanish to explain models and demonstrate.
For the modeling phase, we rejected linear models immediately because the relationship between the revenue and emissions isn't a straight line, but it's conditional. Instead, we chose gradient boosting regressors as our core engine because they naturally capture these nonlinear interaction splits without needing massive amount of data. However, with only 400 training rows, standard boosting models wouldn't memorize the data and overfit. Hence, we used randomized search cross-validation to find the Goldilocks zone. We deliberately constrained the tree depth to 3 for scope 1 and 4 for scope 2. This forced the model to learn general physical rules like sector intensity rather than memorizing specific company names. We also attempted complex tagging ensembles combining ridge regression, random forest, and boosting. But we found that on small data sets, the meta-learner actually introduces noise instead of increasing our error rate from 1.98 to 0.27. We made an engineering decision to cut complexity and prioritize a robust single model over a fragile complex one. So, instead of stacking, we used weighted blending to hedge our risks. We trained 2 variations of gradient booster, one a physicist and 2 a statistician model. By blending them 70 by 30, we created a safety net. If the physical model gets confused by an outlier, the statistical model pulls the prediction back.
A roadblock that I personally faced was not being able to use outside data to train the language learning model. There was actually this one hypothesis that we were supposed to use that proved to be very accurate, especially with the correlation between the target scopes, right? But because it needed the outside mod data, which was basically the PPP, which stands for this, had to be updated yearly, or because a lot of it had to be imported and sometimes the countries would not match up in terms of name, we could not use it because the test data would not be able, sometimes would have certain risk factors that would not allow it to accurately calculate the emissions.
Throughout the course of this Codeathon, we experienced countless meaningful moments, including late-night coding sections, huge learning curve, and countless error messages when performing feature engineering.
And despite that all, including the time restraints, we came up with a successful product that we are very proud of, and we also thank the Fitch organizers for this experience. Thank you so much.